Okay, so this short presentation, I'm going to go through an R package to improve the quality assurance of models. And I'm going to talk through our overarching aim. So overall, what we're trying to do is to shift the health economic modeling pipeline from spreadsheet software, so for example, primarily Excel, to script-based programming languages like R. So if you look at the visual on the right, at the top there, we've got the current system, in which somebody might do some analysis of trial data or costing data, utility data, and they might do that analysis in Stata. They might then create a model using MS Excel, maybe with VBA to try and do probabilistic analysis. They'll then make some plots and visuals, probably in Excel, and copy and paste those manually into Word, and then also create a presentation using PowerPoint. And so the overarching aim really is to shift the industry towards developing pipelines where we have analysis being done in R, models being built in R, plots and visuals being done in R, reporting done in R, potentially using Markdown, and then user interfaces and presentations being done in R through things like Shiny. So, and there's an ongoing movement of researchers, of people, of consultants, those in industry who have an interest in this and are really keen to try and get this pushed forward. And so there's discussions around how do we best do that, which I'm happy to have after the session. So with this aim, this objective in mind, we've published a number of different papers over the years, starting with a paper on making health economic models shiny, living HTA, R packages, last year assertHE, which is the one I'm going to talk about today, and then another paper which we're currently writing on automating health economic evaluation with R and incorporating generative AI in the writing process and the report generation process. So I'm going to talk today about assertHE, but I think it's pretty useful to spend just a small amount of time discussing kind of the lead up to that, because that might be of interest to some people who are newer to modeling in R. So back in 2020 and 2021, we published a paper called Making Health Economic Models Shiny. And this kind of really kicked off, certainly for me and Paul, our involvement and engagement with the industry and those that are building models in R and have been for years. And essentially what we tried to do was build a tutorial, the absolute simplest possible tutorial on how you can develop a model in R and integrate that into a user interface, deploy that online in such a way to make the model more usable and transparent for decision makers. And really the aim here was to allow those that are non-programmers, non-technical, to interact with model parameters and understand the effects of those parameters on results. And that was hugely successful. So absolute ton of interest in this as a concept, and essentially led to us building up the company. We then worked on living HTA and how we can automate out health economic evaluation with R as new data becomes available. And we made the mistake here of building in a lot of kind of more technical stuff around ways in which we can build models in such a way that data doesn't have to be shared externally. So those of you that are familiar with the Open Safely project from the University of Oxford will be aware of this as a concept. So we tried to kind of apply the same thing here. This is a massive failure. So we're a long way off this, and hopefully this will come about in time. But so far, this has been a really slow burn, and a lot of what we've worked on and done here with this paper and this work kind of went over a lot of people's heads. But we then carried on and tried worked on another paper, published another paper on packaging cost effectiveness models in R. This one was much more widely accepted and has kind of gained more traction. We're seeing more models built essentially as packages, and this feeds nicely into what I'm going to talk about today, because I can kind of lay out how one might structure a model they've built in R. So if you see the diagram on the left here, a common kind of structure for a model might be an R folder containing your functions that the model uses, small units of code, small algorithms that stitch together in the center there to form the model. So as we can see, we've got an outer function called run PSA that grabs the model parameters, samples some PSA input data, runs the model, and within that model, there's a whole series of functions for defining transition matrices, creating Markov traces, calculating qualities, discounting, getting results, and then outside of that process, the PSA results are generated. And then you've got your plots and visuals, etc. But each one of these small units, so these green boxes, is its own small algorithm. And so in R, we can completely separate out the code, the stuff that is running these small unit algorithms, from data and user inputs and sensitive data and stuff like that. And so if we think of our model as a set of distinct algorithms, we can then go ahead and review that and review each one in turn. And this diagram here shows a very simple model, the Six-Sigma model, which we use for teaching. But more complicated models, more developed models that might be used in a submission, get much more difficult to review. So now in the past, I've gone to review a model, and I said, yeah, sure, I'll review it, and then you get given the model, and it's like an absolute ton of code, and you go, oh no, okay. So now I've got an absolute ton of code that I've got to navigate. Where do I start? And so that's where the assertHE package has kind of originated from, is from trying to review models that are tricky and large. And so this project was a collaboration across a number of different individuals from different organizations, and the standard disclaimer that these are kind of my opinions and not those of any of these institutions. But the aim is to help modelers build and review health economic models in R. And we originally started with two different sets of functionality in mind. The first being checking that the objects created in the models conform to standard rules. So things like ensuring that as you're building a model, all the probabilities that are in the model are between 0 and 1. Things like making sure that the trace rows always sum to 1. You're not kind of losing or gaining cohort size throughout the model simulation. So it's kind of really standard checks that individuals might already be incorporating into their modeling code, but that again, it doesn't make sense for everybody to be writing the same code. Better to have a package go away and provide all that functionality for you. So that was the kind of primary aim. The secondary aim was, is there a way to be able to summarize and visualize the structure of this model? And this is really what, as I understand it, people are using this package for now. So when I'm talking to people about how they've used it, the stuff in the green box here, plotting the network of functions and how the code is nested and structured, is really how people are using this. So what we do is we create a network visualization where each node is one of the algorithms that make up the model, and we allow users to click on each node to see the function, the name, where it's stored in the code base, whether it has any tests associated with it, and that test coverage, and then also display a large language model generated summary of that function. So more on that in a second. So there's really two ways to use this package. The package is now on CRAN, so you can install it as you would install any other R package. So you just use install.packages, grab it from CRAN, and then call library to load it into your environment, into your namespace, and you can then insert checks for common errors in the code. So this one, for example, checks a time-dependent transition probability array, just to make sure that it operates as intended, and it then flags any potential problems. So if there's transition probabilities that aren't valid for some reason, maybe they're outside of the range of 0 or 1, or they don't sum to 1, or whatever it may be. So there's a nice bit of code there to check those. But then if we look to the right, probably the best use case, or the most common use case now, is to be able to visualize a network of functions and how those functions fit together in the model. So you can see this visualize project function, and what this does is allow you to provide a project path, so path to wherever your project directory is on your machine. If that's already your working directory, you can just set that to be dot. And then you just need to specify where the functions are stored. So where the model functions are stored. So in this case, they're all stored in R. And then also, if you do have tests, where those tests are stored. And then there's another term there as to whether you want to run the coverage of that function. And so you can then inspect the network and understand how these functions interact, get test coverage, and then there's a get GenA function summary. So just to go through this quickly, this is a really simple example model that we used to develop the package. So this is the Six Sigma model, and in the Six Sigma model, it's actually incredibly simple. There's one function called run Six Sigma model, and then there are 5 functions that are called by that model sequentially. So we don't have any we've only got one level of nesting here. There's just 5 sequential functions that are used. And so we can see those all point into the run Six Sigma model. So the run Six Sigma model calls those functions one at a time. So the arrows here point from the code that's being sourced to where it's being called. And we can see that we have these 2 other functions that are utility example and utility example 2 that might just be used externally to that run Six Sigma model function. So they might just be used on the results of it or something to create a plot or whatever it may be. We've just put those in there for our testing. So we can click on any one of those nodes and we can see the name of the function, the location of the function, so where it's located in the code base. In this case, it's located in the R folder, create Markov trace, and line 45. And we can see where the test is located. And if you note that we've got green here for functions that have tests, yellow where the testing coverage is between 25 and 75%. I can touch on that later if there's any questions around testing coverage, and then red if the testing coverage is below 25%. What's quite nice is within the ID that pops up within the HTML output, you can actually add your own nodes. So I know that some people have been using this as kind of a teaching tool, or a tool. We've used it as a tool internally to be able to say, okay, so we have this model, we want to make this small adaptation, and we want to incorporate a new function here. And then you can, that's quite a difficult thing to convey internally for internal meetings with a large code base. But actually, if you can visualize it and show a junior colleague or a colleague that's working with you, collaborating you, oh, we should put a function here that does X, it's a lot clearer to see it on a visual diagram. And send a screenshot or something of this than it is to try and explain that in written text. So then the really cool bit that I've got really interested in recently, as everybody obviously has got interested in large language models and generative AI, is that once we've split out the model into these separate nodes, we realized that actually one of a really nice task for a large language model is to be able to take one of these unit functions that might have, say, 20 to 100 lines of code and produce a summary of that. So if we try and get a summary of our entire model with a large language model, we might experience some hallucination and some issue because we have potentially 100,000 lines of code. If we give a large language model 100 lines of code, it tends to perform quite well, and this is fairly well known and to anybody who's working with generative AI regularly, that it performs much better on small units than it does on larger units. So what we can do is click this robot button, and then up, and then when we do that, we get this large language model summary of the function. And so what happens? So the first thing that we do in the background is we extract the function data. So we pass the function arguments, the body, and the Roxygen, so any documentation that sits above the function, and we store all this as an object in R, and then we insert it into a pre-created template for a prompt, and that template is basically saying these are what the arguments are, this is what the body is, this is where the Roxygen documentation is. Can you provide a summary of this function? And it gives some examples of what that should look like. So it's kind of, I think, 3-shot prompting. It then sends the prompt to a GPT. So by default we're using OpenAI's GPT-4, and then it does that via an API request. It receives the response as text and reformats that text into the correct format to display back to the user, and then shows that GPT response in the modal that the individual is working on, so in this IDE. And then this is the kind of thing that comes up. So it gives a kind of short summary of what this function is doing. And so we hope that what this means is that as you're kind of understanding how the model works and interacts together, you can also then just click on any one part of the model and get a short summary of what that bit of the model is doing. And so we've undertaken a large number of test cases now. So we developed the model first with this assertHE package, assertHE model, and then tested it internally ourselves on 2 models, the CTX2CEA biomarker Excel model developed by Fernando, and the nice RCC model developed by Dawn and Darren. And so we have automated tests basically as we're developing the code base. It kind of essentially tests itself on these 2 models. But then we also asked some collaborators from industry and various projects that we were involved in to please test this code themselves without us getting too involved, or we've tested it on the code without having previously kind of developed the assertHE model on that, and these worked first time around. So it's really good. And so these are external models that have been developed by other people, and then and assertHE's never seen them, so we've not been kind of using them in the development process, and so far that's worked well. And I should say that there's been a lot of use case within industry and consulting, so we're aware of quite a few other consulting companies and people in industry that have been using this assertHE package for internal discussions and things. So thanks for that. And so far as we're aware, there's been no problems, but we're in discussions with other companies and things about ways to improve this. So if you would like to use the package, we're super keen for everybody to use it. Please just feel free, go ahead. It's open source, open access, but we'd love feedback if you do. So just to really quickly go through the CTX2CEA model, there's a short summary there and links in the slides. This is the SHA diabetes model, as you can see there, that's made open source by Dan Pollard at University of Sheffield, and you can see that one on the screen there. So it's quite a nice visual. And this is the nice RCC pilot, an absolutely huge model that we used for internal testing. And so just to say that we have a open access publication on Welcome Open Research that goes through everything I've talked through today, all of the methods and kind of how this works in the background. There's a CRAN package, so it's fully open source. It's on CRAN, so you can just install using install.packages, which is handy for people. And there's no kind of malware and stuff, and all the standard CRAN checks have been done. And then there's the GitHub repository, and we're keen for people to be contributing. So if you want to take a look, try and adapt the source code, make any contributions, then feel free, and we'll review those when you do. So just to share one previous example, if I go here, this is the Sheffield diabetes model that Dan made open source, so thanks to him. We can see here, this is the HTML output, so I'm not going to show you the generative AI bit today, but this is just the HTML, so you can download this from the tool and then share it with collaborators, or use it as a teaching tool, share it with students. But this is kind of how it looks like. So we've got this function here, initialize intervention dt attends se. That function is called by the run simulation function, and the run simulation function itself is called by the run model function. And we can see where all these functions are located. We can see where the corresponding test is located. So in this case, in the unit tests folder, whereas the function was in the R folder. And so this can be a good guide for how well tested a certain model is, which might encourage some more unit testing and internal testing, which would be nice. But it also gives you an idea of how everything fits together. So we can see here some intervention costs embedding function that fits within the calculate costs function, which then also is inside the run simulation. So hopefully that's kind of a useful example of how these might be used. So going back to the presentation now. So the next steps, definitely trying to get some more testing and collaboration. And the other thing is future development. So one of the things we're looking at doing is incorporating our quite extensive course materials now. So we have about 10 courses that are available live or will shortly be available live. And so it would be good to develop and kind of train, integrate using RAG the assertHE essentially chatbot integration, so that a user could talk to the model via the LLM, and then use our training and teaching materials alongside the model to kind of ask questions. It's one of the things that we're looking at doing. And just to share some additional materials, so we have a variety of short courses on a number of different topics relating to this, from introduction to R all the way through to different models like microsimulation and then using things like Shiny and automated reporting. So if you are interested, please feel free to join us at one of our courses. And we also have a reading list for those that are interested in kind of key papers in R for health economic evaluation. So I'll leave those on the slides. I'll leave that up there. Thanks.